that your neurons are also can be irritable, no? Meaning to say they can be disturbed also, no? Especially during action potential, or there are impulses, nerve impulses, or there are electrical impulses along the axons, no? So meaning to say, if they are disturbance of the neurons, there will also be some disturbance in the function of your brain. So it is electrically, the electrical voltage in your brain. So you know that, no, there are potential differences, there are resistance, so there are insulators or even conductors. So it is like an electricity, no, in the, when you have your action potential. So you have also the flow of your different ions. You have also potential on either side of your membranes, the number of ions. So it does not only work with a neurotransmitter, but it works also, your brain works also with different ions as well as the electrical voltage of your brain. So meaning to say, it is the combination of the different function of your brain. Electrically charged, no? The ions, the neurotransmitter, the anatomical, functional anatomy, it affects the function of your brain as well the formation of your brain. So like any other neurons, you have plasma membrane in your brain, no? It is gated channels, no? It opens and it closes, no? So it is, an example is your sodium-potassium channel. So you know this. So when a neurotransmitter is not bound to the extracellular receptor, sodium cannot enter the cell, and potassium cannot exit the cell. So meaning to say, your sodium-potassium goes hand in hand. So when the other one enters, the other one cannot exit. So that is the function of our sodium-potassium. Sodium cannot enter the cell, and potassium cannot exit the cell. However, when this is attached to the receptor, sodium enters the cell and potassium exits the cell. So meaning to say, your sodium-potassium or your gated channel goes hand in hand with your receptors. So there are receptors in your cell membrane that accept the sodium, or there are receptors that accept the potassium. So without the receptors, your channel cannot function. So you can see that when the intracellular environment is negative, sodium cannot enter the cell. Open when the intracellular environment is positive. So when the intracellular environment is positive, sodium can enter the cell. When intracellular environment is negative, sodium cannot enter the cell. So you know that already, no? Why? Because sodium is positive, so it cannot attract. When they are both, when it is negative, the negative attracts the positive. So that's why the sodium can enter the cell. So you can see that there is a great function of your, your electrochemical gradient of your different gated channel. It is elicited by your chemicals and the electrical current of your brain. You can see that an electrical current is created. So it is also, there are also voltage changes across the membrane. So you can see that your ions, it passes from an area of high concentration to an area of low concentration. Also to the electrical gradient, and they move toward an area of opposite charges. So as we said, when the intracellular environment is negative, the positive electrical gradient can enter when it's negative. But if it's negative to negative, of course, it cannot attract the electrochemical ion in your brain. So that's why your sodium, when there's intracellular negative, it cannot enter the portion of your neuron or your nerve. So you have the so-called membrane potential or your action potential, no? So it integrates, send, and receive information. You know that already. Maybe I will not delve so much with this because you know when there is an action potential, it sends messages as well as receives information and integration of different information, no? However, your membrane potential also changes, no? Because of your permeability of your membrane. It becomes permeable to a particular ion and sometimes it becomes impermeable to another ion. So you can see that changes in your membrane potential, no, is caused by depolarization. When the inside of the membrane is less negative, there is depolarization. Repolarization when the membrane returns to resting membrane potential. So when your membrane is already the ions are already inside the membrane, it becomes repolarized. You cannot anymore have an action potential. So the membrane is being at rest. However, you have the so-called hyperpolarization. The inside of the membrane becomes more negative than the resting potential. So when there is hyperpolarization, there is still changes in the membrane potential. But when there is repolarization, the membrane becomes rested. So when we say graded potential, meaning to say there is changes in your voltage of your membrane. So you have your, as I've said, your action potential. There is a brief reversal of membrane potential with a total amplitude of 100 millivolts. Action potentials are only generated by muscle cells and neurons. They do not decrease in strength over distance. They are the principal means of neural communication. So meaning to say, when there is action potential, there is neural communication. The action potential in the axon of a neuron is a nerve impulse. So there is, when there is a nerve impulse, there is an action potential. So why there is a nerve impulse? That is because of the combination of your different voltages, the ions, the neurotransmitters. So it results to your action potential because of the nerve impulses. So here you can see that during resting state, the sodium and potassium channels are closed. And there is a leakage of small movements of sodium and potassium. So only small amount of sodium and potassium gets inside because the channels are closed, or the receptors are closed for sodium and potassium. So you can see that when sodium gates are opened, potassium gates are closed. So you have seen that before, that it is sodium and potassium gated channel. So when the sodium gates or the receptors are opened, it gets inside, while the potassium gates are closed. So in hyperpolarization, potassium gates remain open, causing an excessive efflux of potassium. So maraming potassium kung hyperpolarization. So during hyperpolarization, your neuron is already not sensitive to any stimulus. And again, depolarization, there is depolarization during this time. Insensitive to stimulus and depolarization. Pag hyperpolarization, the neuron is at resting state. It is very full, so they cannot be stimulated, nor there will be no depolarization. So in repolarization, it restores the resting electrical conditions of the neuron. So as we've said before, that during repolarization, your neurons rested, no? So there is redistribution back to resting condition as restored by your sodium-potassium pump. So pag hyperpolarization, there will be no depolarization. It is sensitive stimulus. So when there is repolarization, your neurons go to its resting potential or resting stage. So you have there, you faces your action potential, you have resting state, you have depolarization when there is sodium and potassium gated channel, repolarization, meaning to say at its resting stage. So again here, the neuron can be depolarized again. So they can receive again the different sodium and potassium ions, no? In hyperpolarization, when it beyonds the threshold of your action potential, it becomes hyperpolarized. So that is the phases of your action potential. Resting state, depolarization, repolarization, and hyperpolarization. So you can observe that when there is sodium influx, or when the sodium gets inside the cell, there is depolarization. So positive ions in the inside the cell becomes negative. So meaning to say, when the sodium enters, the inside of the cell is negative. Ions of the extracellular fluid move toward the area of greatest negative charge. A current is created that depolarizes the adjacent membrane in a forward direction. The impulse propagates away from its point of origin. So there is an action potential from one neuron to another. Continuous depolarization. However, when it's already full, it cannot be, there is no stimulus that can receive, it becomes hyperpolarized. So again, as we've said, when sodium gates are closing, the potassium gates are open. That is sodium-potassium gated channel. Sodium inside getting, so when sodium gates are closing, the potassium are open. However, there is threshold of depolarization that is 15 to 20 millivolts. No? So when there is what you call subthreshold, the stimulus cannot function or cannot give an action potential. That's what you call subthreshold. When there is threshold, there will be an action potential. So you can see, you know already what is all or none phenomenon. Either it can have a complete action potential or none at all. No, that is all or none phenomenon. So you can see here the different period, how the sodium, potassium are being carried over inside the cell. As we said, sodium and sodium gates are closed, potassium gates are open, repolarization is occurring. So repolarization occurs when sodium gates are closed and potassium are open. You try to relate that repolarization when potassium are open, repo, P, potassium, open, no? Sodium are closed. No? The threshold level is elevated, allowing strong stimuli to increase the frequency of action potential. So, however, velocities of your axons also varies, meaning the fastness of conduction of your action potential varies from neuron to neuron. So you know that it is determined by diameter or the length, or the bigger the diameter, the faster is the impulse. No? Also the distance of your myelin sheath. The myelin sheath are the one that is that carries the fastness of your what you call that, the depolarization, the action potential. Without your myelin sheath, there will be no action potential. So you can see that a saltatory conduction current passes through a myelinated axon only at the nodes of Ranvier. So without your myelin sheath, there will be no conduction of your action potential. Myelin sheath are the one that conducts, no, your electrical impulses. So it is said that sodium channels are concentrated at the area where your myelin axon are being placed at the nodes of Ranvier. You can see that action potential is just to the next. Meaning to say, it comes from node of Ranvier to another nodes of brain here. So, how many hours are you required in your psychiatry for your whole semester? How many hours so that I can also give you the syllabus? How many hours do you have in your psychiatry for your
18 hours, Doc. 18 hours po, Doc.
for the whole semester? How
Yes po, Doc.
18 hours? 80?
18 po, Doc.
18 hours only?
Yes, Doc. Based